Something extraordinary is happening today, something most people believed was impossible. For years, whispers about Maxwell's mysterious beyond imagination device have spread across tech forums, private labs, and engineering circles. People claimed it could run with unbelievably low input, generate performance no machine of its size should achieve, and even defy long-held assumptions in physics. But all of that was talk until now. Because today, for the first time on camera, you will witness a full, uninterrupted live demonstration. No edits, no cuts. Just the device, the data, and the truth that follows. For months, Maxwell's lab has been under a kind of pressure that most inventors never face. Global curiosity mixed with global skepticism. Engineers demanded test results. Investors demanded proof. Physicists demanded explanations, and the general public? They simply wanted to see whether all the hype had any substance behind it. What made this device so interesting was not just the claims surrounding it, but the secrecy. Maxwell refused to release lab notes. He declined interviews. He turned down offers that would have made him instantly wealthy. Instead, he insisted that the world should judge his invention not by rumors, but by a single, real-time demonstration, something that either validates everything or destroys the myth entirely. Today's video is the moment all of that mystery collapses. Whether you're a seasoned engineer or someone who just loves breakthrough technology, this is the first time you'll see the internal structure, the wiring, the components, and the exact setup Maxwell uses to test this machine. Before turning it on, we'll break down what this device is supposed to do, what the critics say it can't do, and why this live demo matters more than any patent or press release ever could. Here it is, the device that sparked a global conversation. At first glance, it looks deceptively simple, a matte black cylindrical core, mounted on a reinforced aluminum base with two braided power cables feeding into what appears to be a compact control module. No flashy lights, no futuristic styling. Just a piece of hardware that doesn't care about aesthetics, it's built for performance. Maxwell calls it a dynamic resonance engine, though the term doesn't tell us much. What we do know is that inside the cylinder lies a system of electromagnetic coils arranged in a configuration that supposedly reduces internal resistance in ways conventional motors can't. Maxwell claims that this allows the device to operate at extraordinary efficiency, with energy losses so small that many experts simply do not believe the numbers. Next to the device are the measuring instruments, a high-precision wattmeter for input power, a torque load cell to measure output force, a digital oscilloscope to track waveforms, and an infrared thermal camera to monitor heat buildup. The setup is legitimate, no hidden power sources, no misleading equipment, no strange modifications. We scan the table, the connections, and the wiring twice. Everything is clean. As Maxwell steps forward, there's a calmness about him, a confidence that only comes when someone knows exactly what their invention is about to do. He places his hand on the control switch. This is the moment everyone came for. Immediately, the wattmeter spikes to show the input power. It's low, much lower than expected for a motor of this size. At first, the device emits a soft hum, a vibration that feels almost too smooth to be real. The cylinder begins to rotate slowly at first, then faster, then dramatically faster, accelerating in a way that seems almost disproportionate to the small amount of energy being fed into it. We focus the camera on the wattmeter. The reading is steady, minimal power, yet the torque load cell begins to climb. 2 Newton meters, 4-6 higher, the ratio of output to input is far beyond what a standard electromagnetic motor can achieve. Even the thermal camera shows almost no heat buildup, just a slight warm ring near the base, far lower than expected. This is the moment skeptics always challenge. Maybe there's a hidden flywheel. There isn't. Maxwell disassembled it on camera earlier. Maybe the readings are faked. They're not because we are using our own meters. Maybe the load cell is manipulated. It isn't. The increase is visible and consistent. Then comes the part no one saw coming. Maxwell increases the load, applying resistance that should, under normal conditions, choke the device or spike the power draw. But instead, the opposite happens. The resonance engine stabilizes, finding a new equilibrium point with barely any change in input. Something shifts in the room. Everyone expected impressive performance, maybe even unprecedented efficiency, but what we're seeing is something else entirely. The device begins to emit a rhythmic oscillation, a patterned pulse that corresponds with a sudden plateau in the load cell readings. Maxwell had hinted privately that the prototype had a self-harmonizing response, but no one knew what that meant. Now it becomes clear. The device appears to be optimizing itself in real time. We zoom in on the oscilloscope. The waveform, previously typical for a driven electromagnetic system, now shows a near-perfect symmetry, something you rarely see outside idealized simulations. Somehow, the internal coil arrangement is balancing current flow and magnetic alignment automatically, reducing opposing forces and allowing the engine to maintain speed with minimal energy expenditure. This isn't perpetual motion, not even close. But it is a breakthrough in minimizing internal loss, something engineers have struggled with for decades. As the device stabilizes, Maxwell performs one last test. He disconnects a secondary stabilization module, something skeptics claimed the engine could not operate without, but it does. It continues running steadily, proving that the mechanism sustaining it is built directly into the core design. The room is silent. Not because there's nothing to say, but because everyone is processing what this means. Technological breakthroughs rarely reveal themselves in dramatic fashion. Most innovations evolve slowly, carefully, with dozens of incremental improvements. But what we saw today doesn't fit that pattern. This wasn't a small step, it was a jump. Let's break down what makes this significant. Most machines waste insane amounts of energy through heat, friction, and electromagnetic inefficiency. Maxwell's engine demonstrated a level of internal harmony that reduces those losses to near-theoretical minimums. Traditional motors experience dramatic increases in power consumption when placed under resistance. This device remained almost flat. That alone makes it disruptive. This is the core breakthrough. Something about the geometry of the coils and the dynamic feedback loop creates a stabilizing magnetic resonance. It's not energy creation, it's energy preservation. And that philosophy flips conventional motor design on its head. The implications stretch far beyond this test bench. Industrial machinery needing less power, electric vehicles with longer range, renewable energy systems with higher efficiency, portable systems requiring minimal input, aerospace and drone applications. Anything that uses rotational force or electromagnetic systems could eventually integrate a design like this. And yet, this raises a deeper question. How did Maxwell figure this out? What math did he use? What assumptions did he break? What theories did he challenge in order to build a system that behaves like this? There's a reason experts will debate this for years. Not because it violates physics, but because it evolves them. What you witness today isn't science fiction. It's a prototype, a real machine operating in real time, demonstrating performance that forces us to rethink old limits. The debate will continue, the tests will multiply, and more experts will examine this device under harsher conditions. But one truth is already clear: innovation isn't slowing down. It's accelerating, just like Maxwell's engine. If today is a glimpse of what's coming, then the future is about to look very different. Stay curious, stay sharp, and stay ready, because breakthroughs like this don't happen once. They start a wave.